Good afternoon, and welcome to Hand-Wavy Chemistry, where we do not delight in the details, but rather bask in the big picture. Today, it's problem time, where we answer chemistry-related questions. The topic for today is mass, moles, and molar mass. Before we get to the questions, I'm going to discuss what each of those terms means. First, mass. When a chemist needs to measure out a certain quantity of a solid material, they do so using an electronic scale. They measure the mass of the material, as reported by the scale. This will usually be some quantity in either grams or milligrams, depending on what the reaction calls for. Using mass makes it easy to make sure we have the appropriate amount of chemicals. However, if you were reading, say, a recipe cookbook, and it told you to use 76 grams of eggs, you wouldn't find that very useful. You would rather tell you use 2 eggs or 3 eggs. You would like a number, because there is a certain number of eggs that are needed to make this recipe. The same is actually true in chemistry. We need a certain number of molecules for the reaction to be balanced, to work, to not have any byproducts and minimize waste. This is where the mole comes in. When we buy eggs, we usually do so by buying, say, a dozen at a time, a dozen being 12. If we wanted a lot of eggs, we could order a gross. A gross is 144. And there are other terms like a score being 20 that we use in English to represent numbers. A mole is a word just like this. A mole refers to 6.022 times 10 to the 23 of something. So if I needed a mole of helium, I would need 6.022 times 10 to the 23 helium atoms. That's not actually easy to measure out, though. So we need a way to link mass, which is easy to measure out, to moles, which is the actual quantity that we need. And this is where molar mass comes in. For every atom on the periodic table, you will see a number related to molar mass. For example, I was talking about helium. If you look at helium, you will see that there is a 4. That is the molar mass. 4 grams of helium is 1 mole. If we look at carbon, it says 12.01. 12.01 grams of carbon is 1 mole of carbon atoms. So 4 grams of helium and 12.01 grams of carbon actually contain exactly the same number of atoms. Each has 1 mole. Now, we don't usually deal with atoms, we normally deal with molecules. So in that case, you need to add up the molar masses of every single atom in the molecule. For example, water, H2O, we need to add the molar mass of 2 hydrogen atoms to the molar mass of an oxygen atom. So let's look at some problems where we're asked to do just that. In this first question, we're asked, what is the molar mass of potassium chloride? To answer this question, we will need to refer to a periodic table. Looking at the periodic table, we see that the molar mass of potassium is equal to 39.098 grams per mole, and the molar mass of chlorine is equal to 35.45 grams per mole. So the molar mass of potassium chloride is equal to the molar mass of potassium plus the molar mass of chlorine, which equals 74.55 grams per mole. Now we're going to answer a slightly more complicated question. What is the molar mass of lithium nitrate?
So we're going to start in the same way as before by looking up what the appropriate molar masses for each of the elements involved are. The molar mass of lithium is equal to 6.94 grams per mole. The molar mass of nitrogen, that is equal to 14.01 grams per mole. And the molar mass of oxygen is equal to 16.00 grams per mole. What makes this question slightly more challenging is not just that there are 3 different atoms involved, but that there are 3 oxygen atoms in the molecule. So the overall molar mass of lithium nitrate is going to be equal to the molar mass of lithium plus the molar mass of nitrogen plus 3 times the molar mass of oxygen, which is 6.94 grams per mole plus 14.01 grams per mole plus 3 times 16.00 grams per mole, for a grand total of 68.95 grams per mole.
Now that we know how to calculate a compound's molar mass, let's combine that with its physical mass to try and determine how many moles of something we have. There is a formula for this, and it is that moles are equal to the mass divided by the molar mass. And you don't actually have to remember that formula because the units tell you where everything goes. We know that we want moles. The mass that comes out is in grams, and molar mass is in grams per mole. If we take grams and divide it by grams per mole, the grams cancel, and those reciprocal moles become just regular moles. This, looking at the units to try and figure out what the formula for our equation should be, is known as dimensional analysis, and it's a very useful tool to cut down on the number of things you just have to rote memorize when studying chemistry. So let's do some questions now where we're going to take a mass of a material and calculate how many moles there are.
In this question, we are asked how many moles are present in 2.76 grams of sodium borohydride. The first step is to calculate the molar mass of sodium borohydride. This is going to be equal to all of those individual molar masses added together, which equals 37.83 grams per mole. We know that the number of moles is equal to the mass divided by the molar mass. So we're going to put in our 2.76 grams and divide that by 37.83 grams per mole, which gives an answer of 0.0730 moles. This final question related to mass, moles, and molar mass is actually the type of calculation that chemists do all the time. It reads, a researcher needs 0.274 moles of glucose for a reaction. How much glucose should they measure out? The first step is going to be the same as for the previous question. We need to determine the molar mass of glucose, which is equal to 180.156 grams per mole. We mentioned before that moles is equal to mass over molar mass. We can also rearrange this equation to say that the mass must be equal to the moles multiplied by the molar mass. We were informed that the researcher needed 0.274 moles, and we just calculated that the molar mass is 180.156 grams per mole. Multiplying these two values together, we find that the researcher should measure out 49.4 grams of glucose. And if you look at the units there, you can see that the moles and the per mole will cancel, leaving us with just grams.
These types of exercises are useful because chemists often need to figure out how much of a particular solid they need. However, chemists don't just work with solids. They will often work with solutions. Solutions will have Their concentration represented in moles per liter and require a slightly different type of calculation. But that is a story for another time. I hope you have enjoyed this video, and if you have, please make sure to like, subscribe, and share it with your friends. And if there is a question you'd like to see covered in a future problem time, please put it in the comment section down below. Thank you, and I hope you have a wonderful rest of your day.